We are live. Shannon, you can start. Yeah, thanks.
Good afternoon, everyone, and welcome to the afternoon sessions of day 2 of our conference. I hope you enjoyed our fantastic morning sessions, the barefoot ecology talks, which was really remarkable, and also our morning sessions, which were super interesting. I hope you're also interacting. We have a lot of information also on some of the other channels, like the lounge. There's been some fellowships posted by Krishna Kunte at NCBS that you can check out, and also some polls. And please do ask questions and interact. Last night when I was chairing the session with Lisa, there were some ideas that were brought up, like perhaps coming up with a pledge for our community. So I'd love to hear your thoughts on this. So please do put these thoughts in the lounge. So for today, we have 4 really exciting talks, and I'm going to start by introducing the first speaker. Just so you know that this talk is a little bit on the longer side, so we might not have enough time for questions, but Manoj will be able to provide the answers to those questions. We'll see how we do on time. So our first speaker is Manoj Karingamadathil, and I apologize, my American English, despite 7 years in India, does not allow me to pronounce it better. He is very passionate about bird watching, Wikipedia, and open data. He is closely involved in bird monitoring and also is involved with the Kerala Bird Atlas and is a prolific contributor to Wikipedia, which is really great because that needs a lot of oversight. And he uses open access data on birds and other aspects of biodiversity to contribute to conservation advocacy. And the title of his talk is Data Availability of Open Access Biodiversity. Take it away, Manoj.
Hi, this is Manoj Karingamadathil and Firoz, AK from Kerala. And we thanks Citizen Science India organizers for giving us an opportunity to share our small presentation. We are trying to do a small presentation about data availability of open access biodiversity information in Kerala. And we all know biodiversity documentation is very important for our local level planning, biodiversity action plan, and others, livelihood and sustainable development goals. And in Kerala, in 2-3 years back, we have a big flood happened in 2018, and we have a lot of habitat loss in our environment. And for assessment for that, we have faced, I think we have no previous data records available for the analytics part and all. For assessing that, we face very issues. So afterwards, that our community is trying to make do the best for our biodiversity documentation. And one more thing in this area is this is the era of zoonotic diseases, and we know COVID-19 to Nipah. In 2018, so we have also a Nipah outbreak. So for future management or planning things, we need to study more about our flora, fauna around us. Okay, the next thing is for backing this type of data availability, uh, we have a national data sharing accessibility policy in India, and we are documenting these biodiversity related things in past few decades, but the data availability started only in few years. And the concept came from Rio Declaration on Environmental and Development, and the first draft came in 2012. And this is a policy is facilitated to access the government of India on the shared data and informations in both human readable and machine readable format. Okay, and Government of India established a license called a GODL, and it's published as an extraordinary gazetting. February 2017. And about the Rio Declaration, it's by United Nations, and it's called as Earth Summit. It happened in 1992, and a lot of countries signed this declaration, and India is committed to share this type of information through the government data portals. And in Kerala, we have, following the National Data Accessibility Policy, we have Kerala Data Sharing Accessibility Policy. And this is things from IT Mission, Kerala IT Mission's website. And the policy is still in draft stage. I think hope soon it's making action and sharing government level data to public. And yeah, kerala.data.gv also established, and it's less data currently. And when checking the Kerala State Biodiversity Board website, there is a tab for upload biodiversity data, and they are asking to share these informations through email. And we don't know how the informations we can retrieve, and I think it needs some official permission and all. And this type of mechanism currently available in Kerala's biodiversity. And when googling it more, I found a project by national portal, and there is also a state sub portal found. It's called biomis, biodiversity management information. And it's very innovative concept, but the data and other things are very less and purely poorly curated things. And next is the community and citizen science and the open data. And we have mainly the data, main data source is our GBIF, that is a Global Biodiversity Information Facility. It's an international network of data infrastructure funded by the world's governments, aim to provide anyone, anywhere to open access the data. Okay, and in India, it's I think we have good distribution of data. In Kerala, it's more. When checking the Kerala GBF data, we have around 42 lakhs data points. And when checking to the time gap, the increased graph happened in 2014-15. Then we have some rapid growth. And when checking the data sources of GBAF, the eBird observation data set is very high. It's around 40 lakhs observations, and the following iNaturalist have 32,000, and then India Biodiversity Portal have around 8,000 observations. And there are also other small contributions from the other website, other citizen science platforms also. When checking the GBF data, the major one is birds and other reptiles, and other taxa have small contributions. When checking the month level data, we have December, January, February, the migratory peak time. We have very good data, and monsoon time is very less data. When coming to the GBAF, I found a very interesting things, and there is a paper came used by the study of GBAF, flying fox data and prediction of the Nipah virus outbreak. And it's happened before the Nipah outbreak of Kerala. This is very coincidental and a very interesting thing. And this type of research only can do if the peoples or institutions share their data. And the citizens and platforms, so we are trying to look at the first eBird India, and collaborating with Bird Count India, we have a Kerala bird monitoring collective is there, and we have when checking the data 2013 we starting the increase graph, and now it's rapidly growing the data set. We have around 3 lakhs around the checklist we have, and when checking the spatial in this map it's shown the species diversity in 7 to 7 kilometer grid. And yeah, we have around 3,64,000 complete checklist, and we have 5,000 plus eBirders, and almost all district have moderately data. In central part, it's have a high data density. And for eBirding, we have a strong, vibrant community. We have, yeah, we completed the Kerala Bird Atlas. It's a very first project in India for the systematic atlasing effort. It's happened only because of the partnership of communities and organizations in Kerala. It was a very huge effort we did in the past 5 years. And I think there's a presentation related to this Kerala Bird Atlas in this conference. And other thing is we have so many campaigns like Asian Waterbird Census, Onam Bird Count, GBBC, and Big Bird Day, like pelagic and forest bird surveys we have, and we have community meetups and all. And coming to the iNaturalist data, iNaturalist, I think it's a growing started in 2012. Then 2017 we have a rapid growth, and in the lockdown time we have a lot of observations we made, and the community, yeah, when checking that data dashboard, 1,20,000 observation we have, and around 6,700 species, taxa species we have, and 2,700 plus observers. And we have iNaturalist Kerala community very active here, and supported by Kerala Biodiversity Monitoring Network, and we have trackers, observation trackers for 14 district, and also we have thematic project like Birdwatch Kerala, Mothers of Kerala, like things, and the community growing through various campaigns like Backyard BioBlitz, National Moth Week, Spider Week, Big Butterfly Month, and Monsoon Challenge. And when checking to the data part, the research grade data is 43%, and 50% it's need to identify. And the observation contribution by users, yeah, it's just a visualization. And when checking the license of data, most of the peoples are like to do Creative Commons non-commercial observations, and yeah, 36% is CC by data, and CC by ND and CC by SA also there. And I think we need to educate more about the license, and getting more GPI compatible data into iNaturalist. And the next is the India Biodiversity Portal. It's very promising platform, and recently get more technical updates, and now it's very fast and efficient system. Now we have it's happened by the network of so many institutions, and in the India Biodiversity Portal, we have around 42,000 observations, and in the 2020, there is a very high increase in the observation. Mostly it's because of lockdown time, and all the citizen science project have very growth in that time. And yeah, there is also Kerala Biobuilds campaign also there. When checking the distribution of data, central part is very dense in the IBP observations. And that's all. It's just a presentation to share the availability data. I think there are more things to need to share. I think hope soon you all check the or explore the these type of data sets and getting more citizen research soon. Thank you.
Thanks. All right, thank you so much, Manoj, for that really interesting talk and a very, very nice overview of the options. I think we have just time for one question, so please ask more in the Slack channel. We have a question from Nishan, who wants to know how much of your data has been shared in the local in Malayalam, and are they actually, is there any awareness being created in the local languages?
I didn't get that. Can you
how much of the data is being shared in Malayalam, and is there awareness being created in local languages for these various platforms?
Okay, I think we have a lot of training programs, online training programs we did, and yeah, and also some videos for the helping videos also created, and text contents also we circulating through WhatsApp groups and all. Okay, and I think it's still in an evolving stage. I think that's all. We need to explore more things for that.
Yeah, it's very good. And I also appreciate that question, because, you know, really getting local languages is a really key issue for us as well. We heard about that this morning during the Barefoot Ecology session. Thank you so much, Manoj. Thank you for your lovely presentation. I think we'll move on to our next speaker, who is Mittal Gala. Mittal is a program coordinator at NCF, the Nature Conservation Foundation. She works with Bird Count India, and that promotes bird listing, documentation, and monitoring in India. And she's previously worked on visitor engagement and conservation at a reptile zoo in Chennai, and as the chief naturalist at an eco lodge near Ranthambore National Park. And she's going to talk about improving the quality of big citizen science data and what are the learnings from eBird. So we'll hear from Mittal now. Thank you.
If you look closely at this map, you would notice that there are no state boundaries drawn, and all the yellow points that you see are basically checklists uploaded by bird watchers. The brighter the yellow, the more lists from those areas. Since 2014, thousands of bird watchers across India are uploading their bird observations in eBird. As this large quantity of data is made publicly available for research and conservation, it is very important that the data is of high quality. Hi, I'm Mittal Gala, and I'll talk about how at Bird Count India we manage the eBird data from India with the help of several teams of volunteer reviewers who are also experienced bird watchers. Before I go on, I'll briefly tell you about Bird Count India. It's a consortium of government and non-government organizations, formal and informal birding groups, including groups on WhatsApp and Facebook. One of our main goals is to encourage birdwatchers from India to upload their bird sightings to a common platform called eBird. eBird is a global online platform for collating observations of birds. It acts as a digital diary for birdwatchers to maintain their bird sightings. It was launched in 2002 by Cornell Lab of Ornithology, and in India, the eBird portal is managed by Bird Count India. Just like eBird, there are many other citizen science projects that face the challenge that come with big data. For example, the eMammal project archives thousands of camera trap images from across the world. India Biodiversity portal allows users to upload observations of plants, animals from anywhere in the country. Season Watch, a citizen science project that monitors phenology of trees, has over 4 lakh observations. Now let's take one of these citizen science projects and compare their data reviewing process with eBird. While both iNaturalist and eBird are global platforms, the data in iNaturalist is in the form of photographs, and in eBird the data is in the form of observations which are not necessarily associated with photographs. The data curation process for both of these programs is also different. iNaturalist follows a community-driven data curation process, which means anyone can review anyone's photos. But in eBird, the observations are reviewed only by region-specific teams of experienced reviewers. Here you can see an example of how an observation looks like in iNat. So you upload a photo and any user on iNat can agree, disagree, add comments or suggest an ID for your photo. I'll now talk more about eBird, and for this I will like to take you through what happens when birdwatchers upload their observations to eBird. Each observation uploaded first passes through an automated filter. The filter is based on our current knowledge of bird species expected in that region at that time of the year. The filter decides which species are expected or which species are rare in that location at that time of the year. I'll come back to this slide, but let me give you a glimpse of how the filters look like in the back end. So here we have cropped images of 2 regional filters, one from Kutch and one from Bangalore. And you can see that the waterfowl numbers in both the filters are set differently across the year. Any count that is reported beyond the filter count will flag the observation. In other words, any count that is reported beyond the filter count will make the observation in the checklist as rare. For example, in Kutch, the filter for Gagni is set at 50 during the winters and 0 during summer. This means if anyone reports count of 60 Gagni in winter or even 1 Gagni in summer, the filter will flag the observation. Similarly, in Bangalore, Eurasian Pigeon is an uncommon winter visitor, hence the filter is kept 0 throughout the season. Anyone reporting even 1 pigeon, the observation will be marked as rare. So these filter numbers are set based on the current knowledge that we have of that species. And as and when more data comes in, these filters are then manually updated. To be more clear, when you click on Start Checklist in the eBird mobile app, the app takes the GPS coordinates of your location and shows you a list of species, which is basically filter, that are likely to be found in your region at that time of the year. Species that are rare, that is set at 0 in the filter, will be marked as rare. So here in this example you can see gull-billed tern, which is rare in Bangalore. There is an orange box with an R in it. And when you see something like this, the app will prompt you to add documentation, either in the form of photographs or in the form of detailed notes. Here is an example of how an eBird list looks like. You can either add photographs for the rare species like the gull-billed tern, or you can add detailed notes on the species, plumage, size, flight behavior and so on. Coming back to this slide, birdwatchers upload observations to eBird, and if the observations pass through the automated filter, then they will be seen in eBird's public output, such as species map, and those that get stopped by the filter are then reviewed by a team of volunteer reviewers. The reviewers then check if the documentation provided is enough for the observation to be shown in the public output. Also, we have a large community of birdwatchers on eBird, and many of them have rights to flag observations such as misidentified photographs that are seen in the public domain. Currently, we have 160 volunteer reviewers, of which 19% are women. With such a big reviewing team, there are often discussions needed on species identification, changing or updating the data filters, etc. We have found that WhatsApp is one of the easiest way to communicate with these reviewers. So far, we have regional reviewers WhatsApp group in 21 states. Some states like Karnataka and Maharashtra also have district reviewers WhatsApp groups. We have an exclusive WhatsApp group for women reviewers. And issues that are common to all reviewers are discussed in the nodal India-wide group. Most of these state-level groups on WhatsApp work independently, and if there is a need, then BirdCount India team gets involved. Reviewers that are not on WhatsApp communicate with the entire review team through Google Groups. We also organize online video meetings and create short tutorial videos for the reviewers to familiarize them with various aspects of the review process. So what are the benefits of having such a decentralized system where each state works as an independent team? So we realized that having state-level WhatsApp group helps because reviewers are more comfortable in participating in discussions in smaller groups than the India-wide group. In regional groups, reviewers are familiar with each other and hence they are less intimidated. Region-specific data filters, data errors can be discussed more effectively. Sharing responsibilities and keeping track of progress in reviewing records is easier. A quick summary of what we have learned while working with eBird's data. Data quality control is a challenge for large citizen science projects, and several teams of reviewers taking responsibility of their region's data has been effective. In our experience, reviewers are more invested in the data quality from their own region and ready to take charge of it. WhatsApp is one of the easiest way to communicate, and we are making a conscious effort to increase the gender diversity among the reviewers, as we firmly believe that a diverse group of reviewers is necessary to improve the data quality across the country. Let me conclude by thanking all the people associated with BirdCount India team, all our partners in and outside India, including eBird Central and the Cornell Lab of Ornithology. We are grateful to all our citizen scientist birders who continue contributing to eBird, and a big thanks to all the volunteer reviewers who are committed at their work, and without them we would be unable to accomplish this purpose. Lastly, I would also like to thank all our funders and supporters. Thank you.
So thank you very much. That was a really excellent talk, Mittal, and it's nice to see you again as well. So actually, I have a question for you. I'm going to ask it first because it's a burning question. So I'm going to take my prerogative. What about changes in phenology of the species with climate change? Because I know that that's happening. It was actually an issue that was brought up this morning with barefoot ecologists, that they're seeing species in places and times that they wouldn't before with the filters. So how does that work? Are you seeing changes, I guess, or is it too early? Oh, you're muted, Mittal.
Hey, Shannon, I will let Ashwin answer this question because he works with the large data sets, and also I think with him working on the State of India Birds report, he would be a better person to answer this question. I'll just let Ashwin, can you please repeat this question?
So my question was actually about the issues we're facing with, climate change is changing the occurrences, locations, and also timings of several species, including in India. And I'm wondering how eBird is coping with that, or if you haven't had enough data for that yet, or I'm just wondering about it.
So I think we're still at the stage where we are trying to understand these changes in patterns, and we're getting some indications of that. A good example is we've been finding this alternate year fluctuating occurrence of some migrants, such as Eurasian cuckoo in the south. Every alternate year, there seems to be an influx of these birds before they pass on through to Africa. And then again, there's the next year, there's none at all, almost. And then again, there's this big influx. So are these climate-driven patterns, or is it for some other reason? Are these natural fluctuations? I suppose these are answers we'll get soon. But for now, we are still at the stage where we are discovering these new patterns and finding them quite amazing. So, yeah.
I mean, I really think these data sets will be incredibly useful for that question as well. I think maybe in the future. So another question that has come up is that sometimes if this is actually a specific question about eBird, is that if a commonly found bird is sighted in a location, sometimes it shows it as infrequent or rare and asks for evidence which may not be available. So I guess they're asking specifically, how do they cope with that? So this is a platform specific question.
So evidence can need not be in the form of photographs. It can be also in the form of notes, which we highly recommend, and give as much details as you can while you're there observing the bird. And I think that is the most important part. Even if you do not have photos, that's fine.
And I'll ask one more question from Paul. He says that in areas with low internet connectivity, the trail map generated can be a bunch of squiggly and straight lines. Why does this happen? Why does it not pick up from the lost signal? So I don't know if you've observed this as well.
Very rare cases it happens, but it's not the internet connectivity issue. I think it is the GPS. You need to have strong GPS connection. But it's just like a very rare occasion where you will come across a situation like this.
So if there are more questions for Mittal, please post them on Slack so that they can answer them there. And I want to say thank you very much for giving such a lovely description of this really amazing platform that I'm really excited to see more data coming out of, because I think it's very much needed for this country to understand what's happening kind of beyond birds. So thank you so much.
Thank you, Shannon. Thank you.
Okay, I want to move on to the next talk by Swaroop Nayak. And Swaroop is currently pursuing his B.Tech in computer science and engineering at MIT WPU. And his area of interest is machine learning and deep learning. And he has been working with Chatur Ilu's lab, which is under the Facility of Sustainability Studies at MIT, that is involved in exploring tech for wildlife and conservation. And the talk that he is going to be giving is AI-based owl call recognition, a pilot project. So thanks, Swaroop.
Hello everyone, today I'll be talking about AI-based owl call recognition, a pilot project. We will be talking about why did we exactly choose owls. Owls are one of the most important birds of prey, and they keep the rodent population in check, and this is why they are termed as farmers' friends. Owls are difficult to locate and identify based on just visual clues. As they're nocturnal animals, most owls are vocal. Their vocal signals are used by researchers in locating and identifying them. For recognition, the theoretical background is focused on acoustic bird detection using transfer learning in convolutional neural networks, or CNN. And most of the research has been based on several publications surrounding the BirdClef challenge and the DK's competition. The data is collected from the Xenocanto website, which is a citizen science portal, and the data format is in audio and MP3 format, and the file size is from 150 KB to 50 MB. Audio length is 2 seconds to 600 seconds. Like, there's a lot of variation with a mean or the average of 30 seconds of audio files. Sampling rate is varied, but later it is fixed to 44.1 kilohertz for ease of modeling. And then the audio quality, Xenocanto has its own metric, grading from A to E, A having the best quality of audio while E having the worst. And for this, you use 17 owl species. And for that, most of them A to B audio files is satisfactory. But for some, A to D audio files have been taken due to lack of recordings in the database. These are the 17 species which we have used in the project. Implementation. How did we exactly get the result for this? So we start by collecting the data from the Xenocanter website. We convert the MP3 files to .wav files for ease of data handling. And then for later on, we clean the audio. We perform audio augmentation, which we'll discuss later on. And then we merge all the data after segmenting the data, which is splitting the audio files into equal interval of time. Then we convert the audio files into images and we grayscale the images, and later this images will be ready to feed into the model and for prediction purposes. Data conversion and cleaning. Audio is converted from MP3 to .wav file. So the cleaning in this procedure means removal of parts which are having no or minimum sounds, as most of the audio which you have collected is basically static recordings. So it's like 2 to 3 hours of audio files which are having like just a few bits and pieces of owl calls. So simple algorithm has been used for this process. The algorithm entails the removal of parts of audio where the sound level is below a certain threshold, and noise removal was not necessary as the quality of audio was satisfactory. This is the graph which denotes, this is a sound graph which denotes the audio level of audio file. Then we proceed to data augmentation. Data augmentation is basically artificially increasing the size of data set, as not enough data was available for that for the certain species. Then we have performed 3 types of audio augmentation: time stretch, pitch shift, and normal shift. This is the audio file which will be subjected to, which after subjected to data augmentation will look like. Then data processing and modeling. Audio tracks have been spliced into audio tracks of 3 seconds interval for ease of model of data feeding into the model. As a CNN model will be used, the audio files have to be converted to images, and this images will be basically a log-mel spectrogram, which is a frequency by time graph. And then the data has been set in the 70:30 ratio for training and testing purposes. 4 architectures have been used for this classification problem. All of them are using transfer learning. We will talk about this a bit later. The model is basically, the last layer has 17 nodes, which is basically a number of species, which is used for the recognition in this project, with an activation function of softmax, as this is the better function for multi-classification problems. So this is basically the step where the audio signal, which is first converted into amplitude by time graph, is later converted to Mel spectrogram and then log Mel spectrogram for ease of feature extraction. Then these are the models which we had trained on. These are the best models of the 4 infrastructures which we had talked previously about. And the best one is Inception version 3 architecture with optimizer Atom, which has got a validation accuracy of 77%. Conclusion. The model created by us can be converted into a user-friendly application. It can be used by bird researchers, farmers, and laymen to detect owl in the vicinity. The recording data provided by user can further be used for refining the model. Application. This is basically, this will be a basically offline method. So if you ever hear some owls in the background, you just open up the application, and then you just record the sound, and then real time. It's a basically real-time application, and you will instantly receive the result of which owl species that was, whose owl call was detected. And then the future directions. So it's basically fine-tuning the spectrum extraction for feature extraction, detection of multiple species of owls in a single audio chunk, then detection of additional species of different genus. So we don't want to just keep it to owls, we can extend it to many and various species. Detection of calls in poor quality of audio, increasing the accuracy of the model. Currently it's 77.2. We would like to take it up to 85 and plus. And then deploying the model to the edge devices like mobile application in form of an application for ease of accessing and for ease of use. And this is the project itself. Thank you.
Yeah.
Thank you very much for a really interesting talk, Swaroop, especially on the technology aspects of this. There's a couple of questions, one of which is mine. The first question is from Ram. He wants to know if there's any reasons for the data being taken from Xenocanto. Was it an issue of licensing, or was there more data available, or something else altogether?
Actually, it's the combination of the first 2 points. As I said, it's free, it's open source, so it's easy to access and easily available. And we had also tried for the birdnets, the Cornell University's birdnet, but the thing was it requires some licensing, and we cannot actually get to that. And also the availability, as I had mentioned, our basic domain was basically all species in Indian subcontinent, and most of it was present in the Xenocanto website. And the best thing was that it was also labeled properly. So for my research purposes, labeling of data and in the way the data was stored, it was actually like good for me, I would say.
And I have a question, because in my own lab, we do some machine learning, and I'm not an expert on it by any means, but I have a little bit of understanding of it. And it's only as good as the data sets you have. So I wanted to ask you too, like how many owls versus non-owls and other things were in your data set, so that there wasn't this misclassification errors and things like this?
Actually, this was actually as in the topic. I mean, the topic we had talked about. It's a pilot project, so this was just the start of it. As the scope is way too high. Yeah, the scope is like the sky's the limit basically. So right now we have just started with the owls, but later on we can proceed to other species and all that. And the best thing is that we're also right now working on different species of birds in a single audio setting basically. So it could be like 2 to 3 birds are simultaneously calling in the same background, and then we have to detect that. So right now we are working on that, and with that also noise classification we'll be handling with that also. So this is actually an ongoing project, and this is the first step we could say for ours.
Right. Okay. So you haven't tested it out yet.
Yeah, we are in the process of doing that. It's an ongoing process. Yeah.
Right. Yeah. It's a really cool project. So I wish you best of luck with that. I think this is a really interesting way. I would encourage you, if you can apply it to non-birds, just because we've actually been looking at ways of doing this with insects. I know this sounds crazy, but actually you can do it with insects. Wing beats and things like that. So maybe you and I can have a conversation later, because we're interested in that.
Yeah, sure. Yeah.
Ram has a follow-up question. How does BirdNet sound recognition app differ from your project? That's a good question.
Oh yeah, the BirdNet sound classification apps, it has a wider scope, that's true. But the thing is that most of the birds are the common species, and they are only focused for the North American and the European species. And they're trained on those species basically, which are found over there. For the Indian subcontinent, none of such application is right now present, which is like being used massively. So this is the reason we are pursuing this project. And this is the reason this is like different from BirdNet, you could say.
Very good. So I think with time we will move on, but please, if you can sort of answer any more questions on the Slack channel itself. I think there will probably be some more questions as people watch your talk maybe a little bit later in the day if they haven't caught it live. So yes, thank you so much. Really interesting work you're doing. And I wish you best of luck with pushing it forward. I think it's very much needed. So
thank you.
Thank you. So our last talk of this session is coming from Ravi Srinivas. Ravi is a senior fellow and consultant at the Research and Innovation System for Developing Countries. And he's been a visiting scholar at the University of Pennsylvania and also Indiana University in Bloomington. He has published extensively on intellectual property rights, climate change and technology transfer, open source innovation, and traditional knowledge. And his talk today is going to be on citizen science and science, technology, and innovation, the need and a case for synergy. So thank you very much for joining us, Ravi.
Hello. Good morning, good afternoon, good evening. I am Krishna Ravi Srinivas. I am with RIS Policy Research Bank based in Delhi. My abstract is going to talk on citizen science and science, technology, and innovation, need and case for a synergy. Basically, citizen science has been understood in multiple perspectives. A very narrow definition of citizen science looks citizen science more as an initiative by citizens to help the normal science technology process, or as an add-on, or at the most as a few interested groups and individuals who are doing a bit of their participation in contributing to science. This look at science, or this approach towards citizen science, has been in work for many, many years. But in the recent times, a more comprehensive or better approach towards citizen science has emerged. And this is particularly in vogue in Europe and also in North America as well. This approach towards citizen science looks citizen science as a very broader way, conceptualizing citizens doing science not just as a mere contribution in patches or as a simple as a token, but more as a complementary and supplementary to doing science. Taking this perspective, European Commission has recognized that responsible research and innovation can benefit from citizen science and vice versa. Similarly, you find a lot of initiatives in synthetic biology where do-it-yourself biology is linked up with citizen science. This achieves more than one objective, like it demystifies synthetic biology. It develops capacity building among the citizen groups to engage with synthetic biology very creatively, and at times even to come up with alternative products and services. But citizen science as a concept is more like amoeba, in the sense that it can be mixed with anything, it can be mashed with anything, and it can contribute in more ways. For example, to give a concrete thing, you can do citizen science to understand impact of climate change and also to look at how climate change affects biodiversity, nature, and environment. But going beyond that, you can do citizen science not only to understand that, but also to evaluate solutions for climate change. It could be testing of a variety when the citizens or farmers or the end users. It could be the citizens who are going to bear the brunt of any project, or who are going to be affected positively or negatively by any adaptation or mitigation measure. Similarly, if we can combine citizen science with 3D and also some maker labs, then that can revolutionize a whole lot of science teaching and also doing science in not just schools and colleges, but also in so many other contexts. For example, citizen science, when combined with 3D printing and maker labs, can bring in small and medium enterprises at one together, students who are doing technical and postgraduate courses, diploma courses, as well as even high school students, to innovate together. So citizen science conceptually broadly gives a lot of scope for doing many things, although the rubric may be citizen science. On the other hand, we can look at citizen science in a much more better way, conceptually thinking of that as a bottoms-up response or a bottom-up perspective towards science technology innovation. The normal science technology innovation based on the National Innovation System thinks or identifies a specific category of innovations or inventions or the science and technology that is being done in laboratories, funded mostly by the state as well as the private sector, done by qualified experts who have typical educational experience, who have years of expertise, and then that contributes to the National Innovation System. But in the last decade or so, recognizing the limitations of this approach, we have come up with many different ways of looking at innovation systems. And in India, it's a rich source for that. We have grassroots innovation, we have inclusive innovation, we have frugal or jugad innovation. And more than these things, we also have a lot of practical examples of these things. Grassroots innovations, for example, can be linked up with citizen science because citizens doing science and grassroots innovations are very complementary as the idea is same. Whereas in case of inclusive innovation, citizen science can contribute by citizens being users, innovators, adopters, as well as adapters. In case of frugal innovation, again, citizen science can be a key component when we try to improve upon frugal innovation or take the frugal innovation into various aspects. Like the same frugal innovation can be tested by different citizen groups in different places. It could be made better, it could be adopted, and more importantly, all these things can be combined on the platforms, or they can be made to work together. To give an example, an inclusive innovation which has to be adopted widely can be linked up with 3D printing and maker lab on one hand. It can become part of a social lab or a testing lab in another context, and then they can be further improved upon. Now, when I say these things, These things may sound utopian or something impractical. It is not so. What we need, actually, what we need to really think is that first, we need to have a wider conception of citizen science, looking at citizen science not as a mere addendum, but as a major component, if not as something that we can simply do a few things with. We have to have a comprehensive perspective of citizen science. Two, the traditional typical science, technology, innovation policy that does not give much importance to the informal innovations or the innovations from the ground up or innovations from traditional knowledge, grassroots and all, has to take into account this sort of innovations, fix them as a separate category where citizen science can contribute to that. Now, to do that, we need only two or three things. One, we need to have specific incentive mechanisms that can be applied to them. Two, we need to bridge the gap between the formal innovation system that is embedded in factories, R&D laboratories, universities, and then the education system with these things. Three, we need to recognize something which is very unique in citizen science, that citizen science can not only contribute and also do, but it can also be a good source of innovation. It could be a good source of criticism. It could be a good source for mutual learning, mutual understanding of science and practice of science and technology innovation. There are a few things which we need to bear in mind in this. One, in India, we have a variety of traditional knowledges, we have a variety of cultures, we have a whole lot of what I would say, the sheer diversity in farming or any activity you do is amazing and mind-blowing. But these are not fully integrated into the traditional innovation system. Here, if we really want to play citizen science a group, we need to bring the civil society groups also into the picture, people science movements, science clubs. They can be brought into the picture and they can be made part of an initiative where we can give them the space and then the incentive to work together and contribute. Now, that Science Technology Innovation Policy 2020 does not mention citizen science as a separate category. It mentions about it only in passing. But that is not sufficient. We need to go beyond that, in the sense that it has to be made a separate category with a separate policy and strategy. On the other hand, it should also mention that citizen science can be linked up as part of capacity building, as part of technology development, as part of importance of traditional knowledge and other forms of innovation, and also link that with many other things which the science technology policy innovation recognizes, like science communication, public engagement, and public understanding of science. To do this, the traditional approach has to be given up. We need a clear-cut categorical policy on citizen science, basing upon the idea that citizen science can be a major component which can contribute to science technology innovation policy. My understanding comes from a researcher who is working on one hand, science technology innovation, emerging technologies and governance of emerging technologies, and on the other hand on biodiversity, open source, open innovation, traditional knowledge, and other forms of innovations. So when someone like me looks at it, it will be in a broader way. But a typical person in science technology innovation policy may have a totally different approach, totally different view. But I think we need to have a dialogue, in the sense that people who are willing to advocate for citizen science, who are contributing to citizen science, and then those who are in the formal innovation system should at least have a dialogue or a series of conversations as to how we understand each other better and contribute together. To begin with, I propose that either DST or one of the scientific establishments can start a forum or a channel or something like an initiative on dialogue on citizen science as a contributor to science technology innovation in India and take it up from that. Thanks very much. I stop with that. Whatever I've written or whatever is spoken now will be converted into a discussion paper or a policy brief of RIS, and there I will give more examples with references, additions to the references to the literature, citations, and from my own writing. Thank you. Thank you very much.
Thank you, Ravi. That was a really interesting discussion. I also want to point out that on the Slack channel, there is a PowerPoint that's been added to the talk that you can find some of the links and some of the mention of the organizations that are, because you mentioned a lot of really important organizations and issues during your talk, and it's good to have those written down. So thank you. I have a question for you, actually, especially given your experience. And it goes along a little bit with Lisa Rasmussen's talk last night, where she talked about the ethics of citizen science. And one of the issues that was brought up there is that there's not always the same perspective on the value of citizen science depending on who you're talking to, right? Citizens will maybe want to do citizen science for one reason, maybe because it helps them in their daily lives, or it helps, their crops, or whatever the case may be. Academics have another reason to do citizen science, right? And then the government may have a third reason. And when we talk about the synergy that you've so nicely, how do you synergize those different values? How do you get everybody on the same page? Because of course, they may also want different types of citizen science from those value structures.
Sure. No, I perfectly agree with you. There are one thing which we need to make it very clear is that each understanding of citizen science comes from a different perspective based on experiences, working and all. So there is every scope for dialogue. For example, even if you take traditional innovation studies or traditional academic disciplines, we have this dialogue with stakeholders of different type who may not have the same agreed definition. But when you want to work with citizen science, we can try to come up with something like a workable definition to begin with, like a working definition. And this working definition is the way where, okay, fine, I agree this is necessary, but this can be a little more. Okay, I agree that I will give up something, but let us work on this definition, improve upon it, and then do something together. For example, policymakers need not and perhaps will not agree with a very broad perspective of citizen science because they may find it very confusing. But we can come up with a workable definition where we broaden their understanding and then say, look, let us try something doing with that. Let us see, whether citizen science, as we try, can be linked up with climate justice or environmental justice, or with different ways of, looking at science and society, or even democratization of society. So we can bring up certain things more towards a shared understanding, something like workable definitions, and then begin with that. Then think and going beyond the projects, because now my issue with many of the policies is that our policymakers, they think citizen science is equal to some projects. You give them some money, you ask them to do something, but nothing goes beyond that. Rather, you conceptualize that as a broader movement, whether it is related to biodiversity or climate change or soil diversity or whatever it is. Then look at it, how we can bring these things together. Because citizen science clubbed together from so many initiatives, has really made a difference in synthetic biology. I've been watching synthetic biology for the past 15 years or so, and we know that in the initial years there was a lot of skepticism about this open source synthetic biology or synthetic biology. Now this has become more or less mainstream. So that is exactly why I want to say we need to begin with a dialogue, then build upon it so that there is mutual recognition and synergy is being built. Thank you.
I think you brought up a really good point, also with the policymakers, right? About how to approach them. One of the kind of follow-up questions I have to that is, when we're thinking about how governments can support citizen science, a lot of times it's actually with infrastructure, right? So for example, language translation services or data servers or something like that, which isn't necessarily funding the citizen science projects themselves, but is rather funding the infrastructure to support broader citizen science projects. And like you said, that can be sometimes hard to convince our decision makers why that's necessary, because it's not a direct line to the output. So do you have any advice on during this dialogue that I agree with we have to have, how we can talk to decision makers better so that we can, I guess, convince them these things are needed?
No, I have a point here. Let me just make it clear. See, the Indian government has come up with something like sharing of infrastructure resources with so many other institutions. Now, if they be flexible in that policy, that can be used to support citizen science. For example, a laboratory can host 1 or 2 citizen science projects which could be undertaken by high school students or civil society groups or farmers or whoever it is. So when that infrastructure sharing facility for policy is made a little more flexible and made available, we can do a lot of things with citizen science projects as well. And second, funding is more important, but funding alone is not something that's the real constraint. The real constraint is conceptualization, incentivization, motivation, and more importantly, having clarity. Because any of these things, citizen science will have to have something like you say, let 1,000 flowers bloom, let 1,000 ideas come. Then even if 1,000 ideas come, even if say 200 or 300 survive and then flourish, that is good enough rather than having nothing. So I think we should be prepared to look at the diversity, accept the diversity and promote diversity in so many ways, because ultimately citizen science comes with a too clear-cut combination of things which we normally don't associate. Citizens are mere users or someone who told be taught. Science is something elite done in ivory tower. So when we talk of citizen science, we want to bridge, come up with something that is doable by citizens, understandable by citizens, and communicated by citizens. So I think it is possible. It may sound utopian today, but maybe in a decade or so, it could be mainstream.
I hope sooner than a decade. I think we all want to do it right away. That's why we're here. But thank you very much, Ravi. I hope you can answer more questions on Slack as they come in. And I really want to thank all of our 4 speakers that we've had this afternoon. It's been a really fantastic session, very interesting ideas that have been put forth. We will have a short break now and we will come back at 2:30. And please do come back for this. This is a unique effort we're trying this year of having this working group. They've been working for several months on developing a platform and a best practices for citizen science data and considerations. We want your input, which is why we're doing this at this conference. So please join that session. We'll see you again at 2:30. And thank you very much to all the speakers. Fabulous job. Thank you.
Thank you. Bye.